So this is the Master Exam Review of Power Standard 7. So we're starting off with rational equations and graphing them. Okay, so based on the base equation of 1 over x, we're going to transform it using this equation over here. Since the plus 4 is on the inside of the function, it's being added or subtracted. It's going to be a horizontal shift to the left by 4. And the minus 2 is going to be a vertical shift down by 2. So we're going to take the points that we have in our equation, our graph, move them to the left by 4 and down by 2. So I'm going to make this middle one right here go left. I'm going to actually do this in red so it doesn't blend in. So you go 1, 2, 3, 4, 1, 2. Oops. Right here is one of the equations or one of the graphs. Okay, and then the other one's going to go left, 1, 2, 3, 4, down 1, 2. Oh, hold on. Put it in the wrong spots. There we go. I'll get it. I can't draw a straight line. There we go. So that's where our new graph should be. Okay, both graphs were transformed or translated to the left by 4 and down by 2. Now let's go back to our information over here, our domain. The graph starts off all the way to the left at negative infinity, but then it has a problem because at negative 4, that's where one of the asymptotes is. So we're going to go to negative 4, but we're going to be a parentheses. We're going to jump over negative 4 itself and start back up on the other side of negative 4 to positive infinity. The range has some of the same problems. It's going to start down below at negative infinity. It's going to go up. But when it hits negative 2, it's going to have to jump over an asymptote, start up again on the other side of negative 2 towards positive infinity. So your vertical asymptote is going to be right here at negative 4, so that is x equals negative 4. Your horizontal asymptote is going to be right here at negative 2, so that is y equals negative 2. And for your y-intercept, if you put 0 in for the x term, you're going to get 1 divided by 0 plus 4 minus 2. That's going to tell you your y-intercept. So we got 1/4 minus 2. I'm going to make this into a nice, beautiful fraction. Gives me negative 7 over 4. So the y-intercept is going to be 0, comma, negative 7 over 4. Okay, and that's all the information for this equation and graph. Next, number 2. Describe the combinational transformation of this function. Okay, there are 3 transformations. Here's 1, 2, and 3. The first one is a vertical compression by 1/2. Next, we have a horizontal shift going to the right by 3. And lastly, we have a vertical shift going up by 5. Same idea in the next one. We want to do the transformations. There's actually 4. There's the negative sign, the 2, the plus 1, and the minus 3. The negative sign is first. It is a reflection over the x-axis. The 2 is going to be a vertical stretch by 2. The plus 1 is a horizontal shift it's going to the right, it's going to the left by 1. And lastly, the negative 3 is a vertical shift. It's going down by 3. Those are the 4 transformations. Okay, again, we're looking at transformations here. Since it's a little bit harder, there are 3. There's the negative sign on the inside, the 4 on the inside, and the plus 9 on the outside. So Negative on the inside. Unlike the last problem we had where the negative was on the outside of the function, this is on the inside. So it is a reflection over, this time, the y-axis. The 4 on the inside, this time it is a horizontal compression by 4. And lastly, the 9 is a vertical shift going up by 9. Okay. X to the 6th, this graph, we're going to just kind of sketch the graph over to the left here, will look something like this. Okay, so that means its domain, since there is no restrictions on what it can be on the x-axis, is from negative infinity to positive infinity. For the range, notice the graph does not go underneath the x-axis. So that means the range is from 0, oh, that should be a bracket though, to infinity. Okay, it does touch the x-axis, which is it is 0 with a bracket, to infinity. All right. The inverse of this function, the inverse of the g function, if the g function is x to the 6th, the inverse is going to be the 6th root of x. Okay. Now, one thing is, for this problem as we move forward, is that we've restricted its domain so that we're only looking at if x is greater than or equal to 0. So what that looks like in a sketch of the graph over here for g of x is we're only looking at this part of the graph. We're not looking on the left side because we're not looking at the domain of anything that's x is less than 0. So the graph's going to look like that, where we're only looking at the x-axis that's greater than or equal to 0. Okay, so the domain for that graph is going to be from 0 to infinity. And the range is the same thing, from 0 to infinity. Now the inverse of the function, if this is g of x, inverse of g is going to be this. Okay, and we did it, we restricted the domain so we could have an extra inverse. Otherwise, there wouldn't be an inverse because it would be a degree function, a power function that has a degree that's even, and also it would not pass the horizontal line test. So by restriction its domain, we made it invertible. Okay, now the domain for this inverse function is going to be, again, 0 to infinity, and the same thing for the range. Okay, that's it. Oh, we've already sketched the graphs, but we'll do it again for this part of the problem. Here is g of x, and here is the inverse of g of x. That's pretty simple. And that's it. All right, so good luck on this standard, and